Thank you for the person. I'm Yosuke Yamazaki. I worked steel companies in Japan. I would like to talk about evaluation of wheelwear property with scaled roller test rig. Let's go. Today's contents was as follows. Let me see introduction. The prediction of wheel and wear rate is performed often using the wear rate function expressed in of sigma by 8, the wear rates. And the wear rate function is usually identified using two-roller wear test. But it is difficult to measure T, gamma, and A for wheel due to the complexity in the contact geometry and pressure of multi-point contact and flange. So we suggest to evaluate the wear rate function of the wheel flange, throat, and thread for the wear simulation using scaled roller test rig and the multi-body dynamic simulation. This slide, firstly, so I talked about wear test with scaled roller test rigs. This slide summarizes the test specimens. Test materials are class C, wheel steels 0.7%, carbon, and microstructure is pyrite steels, and the stiffness is 330. And wheel test specimens were taken from the actual wheel rim, and roller test specimens were taken from the material billet for wheel. And this figures wheel and roller profiles. Wheel profile is a type of AAR standard with a scale ratio of tens, and roller test it's a type of AREA type, and the AREA standard with a scale ratio of tens. And this shows the several test conditions. This test so each whole specimens in contact with roller specimens, and the whole specimen is driven by the roller specimens. And this in the roller side revolutions, the driving revolutions 300 RPM, and wheel side driven revolutions 500. And it's whole specimen, so it's applied vertical force and lateral force, and rollers in the rollers so that's the attack angles, and this case is 5 situations, and we changed vertical force and lateral force and attack angles and wheel and roller diameter. The case 2 is half lateral force of case 1. It's aimed at degrees lateral forces directly. And case 3 is an attack angle to case 2. This is aimed at increasing lateral forces indirectly. And case 4 and case 5 have different outer and inner diameter. This is aimed at increasing longitudinal creep forces. This slide shows the test result. This figure shows the relationships between the rolling distance and material loss. The red lines, outer wheels, and inner wheels, blue line. in case one conditions. From this figure, the material loss of the outer wheels is larger than that of the inner wheels. And these pictures the surface of wheels after test in case one, outer wheels and inner wheels. And this figure shows wheels profiles each test, and in case one, so outer wheels and inner wheels. So, from this figure, the outer wheels is 1 at flange and throat area, and the inner wheel is 1 at the thread area. This figures the loss of material per unit travel distance, m by d, compared to all case. And the loss of material per unit distance, so out of wheels larger than inner wheels. And this embodied values difference of the all cases. Because, for example, so MYD of case 2 is smaller than that case 1 in case 1. Because so this figures applied lateral force of case 1 bigger than the case 2. And MYD of, for example, the case 5 is larger than that in case 1, because this figures longitudinal force of case 5 is larger than that of case 1. And this slide so evaluation method of wear property. So it is usually this parameter T gamma and A is obtained by the two wear test, the two roller direct and evaluation of wear rate with T gamma. So, but it is difficult to measure T gamma and L in flange, throat, and thread separately contact. We suggest the T gamma and L of each contact point calculated using the multi-body dynamic simulation. This is simulation model summary, and this tables components and degrees of freedom. The whole setters for lateral direction and vertical direction and roll directions and pitch directions for DOF. And whilst roller degree DOF, so only pitch directions. This figures result simulation and where simulation and test where the longitudinal forces. This red lines outer wheels and blue lines in inner wheels. So, and the simulations point, so each the long distance profiles using. So it's the simulation result only 4 points. So the calculator longitudinals for associates are almost same as test results. And this figure shows the relationships T gamma by A and wear rate, and red point flange contact, and green lines green points throat contact, and the blue thread contact, and black the reference is twin disc wear map. So from this figure, the wear rate of the thread and the throat and flange clearly separated. And under the flange and throat wear rate are higher than that of the twin disc test result. This figure aspect ratio of Hertzian contact areas, thread, throat, and flange. So from this figure, the flange contact has sharply ellipsed along the wheel rotation and the direction. It is strongly this aspect ratio of Hertzian contact area to wear rate. And this result, this figure, select the same T gamma by A values and wear rate through thread contact and throat contact and flange contact. So this and the right side of the figure, so it's this points T by A and slip rate. So that's this result from this result. So T by A's its flange it's larger than thread, and but separate thread smaller than flanges. Actually, the thread larger than the flanges. So T by A has a very strong correlation to the wear volume rather the gamma. And lastly, this figures the microstructure and hardness after test. Thread, throat, and flanges. This figures microstructure and hardness of the wheel after test different for each area, and because throat and flange areas very high high force of this area, so it's and after that, throat and flange of the surface locally, plastic plastic strain the open. Okay, this conclusions in this studies where function for the T gamma wear map evaluated using scaled roller test rig and multi-body dynamic simulations. First, the outer wheel specimens with flange contact have larger wear volume than the inner wheel specimen with thread contact. Second, the wear functions for the flange, throat, and thread areas are obtained as different function. The flange area has the highest wear rate, and the thread area has the lowest under the loading condition, considering in this study. And number three, so flange and throat area have larger T by A than the thread area, the same T gamma by A. This indicated that T by A has strong correlation to its wear volumes. Thank you for your attention.
Thank you very much.